Hello guys, welcome to part 8 and what should be the final episode of this timing repair series. In part 7, I installed the camshaft adjusters, the front covers, the valve covers and everything that needed to be installed to make the engine ready for installation into the vehicle. In this final episode, I skip all the engine installation steps as most people doing this job do not actually need to remove the engine. As I said earlier, I removed the engine to enable me to resolve some leaks I was dealing with. I will go straight to the first engine start after completing the timing job. I will look at the check engine light codes that ensued and what I did to resolve them to get the vehicle back into service. So beginning with the first after repair engine start, let's go. Starting. You're running okay for now. Woo! What a hose! What a hose! What a hose leak! I honestly wasn't too surprised by that. Those annoying lock clips can be temperamental, but that was a quick fix. I used water as coolant because I wanted to run the engine with water to make sure everything was fine before I used coolant. Coolant isn't exactly cheap. Alright guys, so first start went pretty well, except I got some coats in addition to the coats that I had before. Now the coats that I had before, one had to do with the intake manifold. They said something about flap adjustment, which I think had something to do with my broken hose, but that got resolved when I was putting everything back together, so that's gone. And then the one that actually got me to take the engine apart is also gone, which is constant camshaft adjustment. That was P0016, P0017, P0018, P0019. They are all gone. Now, those were hard coats, so when I started the engine, I cleared them, then they didn't come back. Now, the ones that I have now are Misfire on cylinder 4 and 5. And then, so that's P0304, P0305, respectively. And then I have random misfire, P0300. And then I have one for the right oxygen sensor, upstream oxygen sensor. So the next thing I want to do is to attack the O2 sensor heater circuit.
Okay guys, so this is the oxygen sensor we're looking at, and this part here is the heater portion of it, and this side is going to be the sensing side of it. Okay, now our problem is confined to the heater part of it, so we're going to ignore the sensing part of it and just focus on the heater part of it. Okay, this side. So let's go back and undo all the stuff here. Now over here we have right O2 sensor upstream of TWC. That's a three-way catalytic converter. Okay, that's what that is. Alright, now you can see the heater has two wires. There's a red and green, and then there's a green. Obviously one has to be a power and one has to be a ground. The question is, which of these is power and which of these is ground? Now in most of these systems, about 99.9% of these systems, the heater circuit is controlled through the ground wire by the ECM, meaning that the ground wire is specific to that heater element. Okay, now if you look at this diagram here, you can see that with these two wires, the red and green is actually being shared with other components. You look at this, there's a splice here, it's sharing this with the heating system shut-off valve, and then you come down here, it's sharing this with the other O2 sensor, the other upstream one on the other bank, the left bank, and then you keep going, you're sharing this again with, you know, the air pump switch above valve. So, you know, obviously if you think about what we're talking about, the fact that the heater element has to be controlled specifically by the ECM, obviously this line that I've highlighted here, which is the red and green wire, has to be the power, and this green has to be the ground. Okay, the ground is being controlled by the ACM, so it cannot be shared. Okay, it cannot be shared because that is specific to the heater element. Okay, all right. Now, the purpose of the heater element is basically to bring the oxygen sensor up to operating temperature so that it can start giving accurate readings for fuel control. The oxygen sensor upstream of the catalytic converter is for fuel control, and the one downstream is for monitoring the efficiency of the catalytic converter. Okay, so now we're dealing with the upstream one, which is for fuel control. So that is what this sensor is for. Now it is controlled through duty cycle. When the ECM pulses this green wire on and off, it controls the heater circuit through duty cycle. Obviously, when you first start the engine, you know, the sensor is cold, the engine is cold. In order for the sensor to come up to operating temperature quickly, the duty cycle will be higher, and as it warms up, the duty cycle will be lower. Okay, so that is basically how the system works. Now let's trace this wire here and see where the power is actually coming from. So if we trace this wire, keep going to the left, you can see it goes to wire number 1 here. So let's go to the page before and see what wire number 1 is all about. So over here we can see wire number 1 on the page before, and that's the same wire, red and green. You can see we keep moving, and you know, there are actually other components here that are sharing power. The power steering, pressure regulator valve is sharing that same power line. Okay, and you know, a couple of components here. I'm not going to go through all of them, but basically all these components are sharing power with that oxygen sensor that we're looking at. So this wire leads over here, and we keep following that wire. Becomes number 3 here. So let's go to the page before and check out number 3. So here is number 3 on this page. Okay, so we can see red and green still, number 3. We keep following that. Okay, we come up here, red and green, it becomes pink and black. So there's a connector here, and that changes to pink and black. Okay, and then it goes into this load compartment fuse and relay box, right rear of cargo area. Now what's going on in here? So basically, if we look at this, we can tell from just looking at it that in order for this power to come down here, right, in order for this power to basically come down here and go to our oxygen sensor, there needs to be something has to happen with this relay. Okay, with this relay right here. Now let's look at this relay here. If you look at this relay, the coil of the relay is here, and you can see that if we follow this side of the coil, say this side of the coil down here, this red and black, it goes all the way here and then comes down so, and it comes here, and then that leads into the ECM pin number 16 right here, and that is circuit number 30. Now circuit number 30 on these European vehicles most of the time just means that it's battery voltage, okay, that is being routed into the ECM. So what this is saying is that there's battery voltage going into the ECM, and then it's coming out of the ECM, and it's being routed here through these wires, these wires into this load compartment fuse box. Now if you actually look at the power distribution box, the power distribution diagram of this vehicle, it shows there are a couple of fuses in which power travels through, and then power goes into the ECM. So let's go take a look at that, and then let's come back here and continue our analysis. Alright, so now before we take a look at that power distribution diagram, I want you guys to take note of this fuse here, fuse number 120. It's a 10 amp fuse, okay? Take note of that. Alright guys, so this is the power distribution diagram, and this is the ECM we're looking at, and you can see there's a fuse here. This is the 120 fuse number 120, the 10 amp fuse we're looking at. You can see that. Okay, now the question is, what is powering this fuse number 120? Over here, if we follow to the left side of it, if we follow this here, okay, so fuse number 120 goes this way, you follow to the left side of it, right, we can see that it says from fuse number 109, looking at G right here. So if we go find G is right here, okay? And then if we keep following G through, right, okay, where does G get power from? You move up here, you can see the power is coming from fuse number 8. It's a 100 amp fuse right here. So fuse number 8 comes all the way down here, and then it goes through and powers G, and then G goes to power the other fuse that powers our ECM. But then we go up again and we look at where fuse number 8 gets power from. Fuse number 8 comes from, this is the battery. You can see that right here. Okay, so that's what I was talking about. I wanted to show you guys this. So that ECM is actually being powered by the battery, and that is circuit 30, what I was talking about earlier, from the engine performance diagram. So let's go back and get back to our performance diagram and see how that voltage actually gets to our oxygen sensor. Alright guys, so now we are back. Now let me erase this fuse number 120. Just wanted to show you that for the power distribution diagram, but I think we've done that already, so I'm going to take that out. Okay, now I think now you guys understand that, based on what we talked about, then obviously the voltage is going to come through here, and it's going to basically come through this fuse and wait over here, because there's an open essentially in the relay. Now, how does the power actually get to our oxygen sensor? So what has to happen is so if you go to the other side of this coil, okay, in the relay, you follow through this coil, come down over here to this brown wire on pin 27, the ECM right here, circuit HR, that is going to be the ground. So what's going to happen is for the power to actually travel to the oxygen sensor, the ECM will activate this ground. When it activates the ground, this circuit is going to get, this coil is going to get activated. It's going to close the circuit like so, and the power is going to travel through here, all the way here, and join up with the wire we had drawn before, and travel through fuse 104, the 15 amp fuse, and then make its way down all the way to the oxygen sensor and all the other components. Okay, so that is it for the power side of the oxygen sensor. So now to the ground side of the heater circuit. So I'm going to use a different color than the color I have for the ground side over here. So we trace the ground wire, the green wire, all the way down. Okay, and let's follow it down. Follow it down here, and it goes all through. It becomes number 29. Okay, so let's go find number 21. Let's go find number 29 on the next page. All right, so number 29 is right here. Green wire, follow through. You can see it goes straight to pin number 49. Okay, and see, this is not shared. Okay, like I said before, this cannot be shared, and it's on connector M1 and pin number 49 on that connector. Okay, so that is it for the ground wire. It's pretty simple for the ground wire. Remember, the ground wire is going to be controlled by the ECM, so it cannot be shared. Alright, so that's it for how the circuit is being controlled. The heater circuit is being controlled on this oxygen sensor, this vehicle.
So now let's get into how the heater element is controlled. So let's go back and try and draw something here. I'm a terrible artist.
This is our heater element, okay? The rest of the circuitry is going to be on this side, but we're not going to worry about that now, okay? There's a heat element. We've got a positive wire coming out and negative wire coming out. Now, positive wire here, obviously, is being powered by a fuse. Well, a symbol for a fuse. Okay, and then we got that. And then it's positive, then negative. That way, that goes into the ECM. Okay, and there's going to be a grounding circuit instead of the ECM to simplify things. Okay, this is the O2 sensor. All right, okay, now, so if all the wiring and the heat element, if the integrity is in place, if you actually take a voltmeter and you measure voltage here, plus, minus, right? Put your plus meter here, and your minus meter goes to a ground, you should get 12 volts. Because we have 12 volts coming in here, going to the heater. If there's no open in it, remember the one we have says there's an open circuit in the heater, so we'll check that here shortly. But if there's no open in it, it means the voltage is going to go in and it's going to come out, and you can measure the voltage here, and in fact you can measure the same voltage right here. You should get 12 volts here too. Okay, now the way this is going to be controlled is, you need a power and a ground. So basically the ECM is going to turn this whole leg on the other side of the heater into a ground. So it's going to be power, ground, basically is what's going to happen on this line here. So this wire here. So if we actually scope this is what we're going to see. Let's say the on is actually going to be 0 volts, because if we're on this wire here, when you ground this wire is when the heater circuit is actually being activated by the ECM. So on, it's actually going to be 0 volts, and off, it's going to be 12 volts. Okay. So looking at this wire here, it's going to be 12 volts all the time if the ECM is not activating, or it's not activating the circuit here, this ground circuit. So it's going to look like this. Once the ECM starts activating it, it's going to drop to 12 when the circuit is working, when this heater circuit is being made hot. Okay, the heater element is being made hot. And then it will change to that when it stops doing, the ECM turns this back off, deactivates the ground. So basically we're going to have ground, power, ground. So release the ground, activate the ground again, release the ground. Okay, now, so this is going to be on, off, on, off. Now, as the heater gets hotter and hotter, there'll be less need to keep it on. So we're going to see something like this. Okay, we're going to see, if we started from here, let's start from here just to make it easy. We'll get less on time and more off time. Less on time and more off time. Less on time and more off time, like so. Okay, this is what we're expecting to see from a properly working circuit like this. Okay, so what I'm going to do next is to, first of all, measure a voltage on the other side of this circuit here. I'm going to measure a voltage over here and see if I'm getting my 12 volts coming out of the heater circuit and coming over here. If I do get 12 volts, it just means that my open is elsewhere, because my ECM is seeing an open in the circuit somewhere. It means my open is elsewhere. If I don't, then I'll probably move here and check if I'm seeing my 12 volts here. Okay, but I don't think we have to get that far. Usually the problem is found in here actually, but let's go take a look and then we can decide what to do from what we find. All right, so the oxygen sensor connector is underneath the car. So I'm going to pick it up and we take a look at it. Not too high, because remember, I've got to set everything up and I've got to go key on, engine off. Okay, so I don't want to send it too high. All right guys, so here I am with the connector. Oxygen sensors on this side. This side is for the ECM. So, you know, they go together like so. Okay, just wanted to show you. Now, the colors we have are, if you remember, we had red and green for the power side, and then we had green for the ground side. So those colors actually match the side of the ECM, okay, not the side of the oxygen sensor. So you need to look for those wires on the side of the ECM right here, okay? So you can see green over there for the ground, and then red and green for the power. If you look on the oxygen sensor side, we don't have those wires, okay? We don't have them over here. You're not going to find that here. You need to look at that on the ECM side, okay? Now, this is what I want to check. If you remember how the voltage came in from the red and green, okay? Came in from the red and green into the oxygen sensor, back out, and then into the green one, into the ECM. So I want to do just one test, I guess 2 pieces of test. I'm going to test the red and green wire to make sure the voltage is going in, and then test the green wire to make sure it's coming out. So I'll do key on, engine off. All right, so key on, engine off. I have these 2 wires tapped into. This one, the red and white. Sorry, this one is the red and green. And this one is the green. So this is the power line, that's the ground line. So what we're going to do first is measure the red and green to see what voltage is going in, if there is battery voltage going in, okay? So what I have here is these are the tips of my power probe right here, okay? I'm going to use the ground side of my power probe to as my ground for my multimeter. But first of all, I want to prove to you that the ground is actually a good ground. So I'm going to run a test light from the tip of my power probe. A test light from the tip of my power probe right there. The other side of the test light is going to be so. Come here, so. Trying to get that right. Tip of my power probe has my test light clip. The other side of the power probe is going to have the other tip of my test light, and I'm going to activate it, and my test light should light. You can see the test light is lighting, so I do have a good ground at the tip of my power probe. Okay, so we can go ahead and test now. Okay, my test light away. So my multimeter ground, I'm going to put that on my power probe ground, and then I'm going to measure the voltage over here, like so. And as you can see, over here, we've got 12.12 volts, which means that we've got voltage from the ECM going in, okay, 12.12 volts. Voltage from the ECM going in through the red and green wire, going over into the heater circuit. Now I've got to measure this one and see if it's coming out. Okay, let's measure that. So take that from here, put it here, see what we're getting. we're getting 4.91. So the voltage going into the heater circuit is not coming out completely, okay? Some of the voltage is being dropped in the heater circuit, okay? So that heater isn't working properly. I don't know if we should scope this. You know what, let's scope this and look at what it looks like on the scope. So I think right now we figured out that we need to replace the oxygen sensor, bank 1, sensor 1. Now, the other two codes that I had, my scan tool is dead, but the other two codes that I had were Misfires on cylinder 4 and 5. So I want to take a look at that. Now, this is bank 1, that's bank 2. Bank 1 goes 1, 2, 3, that's cylinder number 1, 2, 3. And then bank 2 goes cylinder number 4, 5, 6. Okay, so I'm having 4 and 5 misfiring. I just want to first do a visual inspection and then maybe do some good old swapnostics first, you know, and see where I want to go from there. So let's take the stuff off and take a look at, you know, my swap calls or whatever based on what we see, but let's take a look at that first. Guys, check this out. Cylinder number 4. Check this out. It wasn't in properly. I just basically started here. I didn't push it in properly, so it's in now. Very nice. Now number 5, same thing. Check this out. I'll tell you, it doesn't get any easier than this. Let me lock them in. As a matter of fact, let me make sure 1, 2, 3 are all pressed in properly. So I think what I did was, while I installed the ignition coils on correctly and all that, and I actually put the connectors in, I just didn't press the lockers in properly. So that's where that comes from. So basically what this means is I'm down to one code, which is going to be the O2 sensor code. All right, start. All right, guys, I don't know if you guys can hear me, but I've got the oxygen sensor circuit scope. Channel 1 is going to be a voltage scope, and then channel 2 is the current probe. I want us to look at the voltage and the current on the circuit, and then we can compare it to, so this is the bad, we can compare it to the good. So let's go over to the scope and let's see what is happening over there.
As you can see, the scope is showing the 4.91 volts we observed during our test. Also take a look at how much the ECM is struggling to ground the heater circuit. It's barely grounding it. This means it will take the heater a long time to warm up the sensor. Here is a zoom in. I set the scope to 10 volts because I was expecting to see 4.91 volts max. On the good sensor, I will set it to 20 volts because I'm expecting to see something close to alternator voltage or battery voltage at the very least. I just changed the time scale to show more data points. Let's take a look at the good sensor.
Okay guys, so I picked up a new sensor. Here it is. Let's try it out. All right. So switch that over to that. See, we're getting awesome reading, 11.75. So this new sensor is good. All right guys, so I'm going to leave the probe right where it is and I'm going to install the new sensor over there. Okay, and then we can check the signals again. We can scope the new sensor to see what the signals look like compared to the old one. So let me get the old one out. I hope you guys can hear me over the sound of the engine running. So we're gonna go to 20 volts because we know we're dealing with a 12 volt scale. And let's adjust the time. Now you can see over here, we've got a nice clean waveform, but more importantly, you can see this goes up to, let me pause that. This goes up to about 12 volts, 12 point, let's say 12.6 volts right there. I mean, we can pull up and measure channel A, the whole trace. It's going with battery voltage, which is roughly showing about 15.2 volts right now. But like I said earlier, as time goes on, the on time will reduce and then the off time will increase, So down here is when it's grounded, the circuit is grounded here at 0 volts is the on time. And then up here, when we have our 15 volts, let's just make it 15 volts, is where we have our off time, okay? Because remember, the ECM is actually grounding this circuit, and the heater doesn't get, heated until the ECM has grounded it. So basically, that's what we're seeing here. So I think this sensor issue is resolved. The waveform looks good, and we can put that issue to bed. All right, guys, so thank you for joining me on this series. It was nice having you guys with me and, interacting with all of you. This is going to be the last video in this series. Obviously, this video itself wasn't even about timing at all, but it's something that happened after we'd finished the timing and we had, started the vehicle, and, I got those codes and then I just had to resolve them. So the car is pretty much ready to go, except I do have a power steering leak. I don't know what's with Mercedes-Benz and leaks, but if you have a Mercedes-Benz and it doesn't leak, you don't have a Mercedes-Benz. But anyway, so I'm going to fix that leak and then the car should be ready to get back on the road again. And again, thank you guys for joining me, and I'd appreciate your subscription and turn on notifications. Thank you again, and see you in the next video.